Everyone, we will solve this today's LeetCode problem. So this question is linked list in a binary tree. So this question is more than binary tree, not a linked list, but yeah, this is combination of two data structures. So yeah, let's see. Given a binary tree root and a linked list with head as the first node, return true if all the elements in the linked list starting from the head correspond to some downward path connected in the binary tree. Otherwise, return false. So statement is bit confusing. Let's see what the question is asking. So here, downward path means a path that starts at some node and goes downwards, right? What does it mean? That if the head, which of the linked list, right? Head of the linked list is this. So this is 4 to 8. It's a linked list, right? So this linked list is a part of in this particular route, right? It will start from 4 and move downwards in a same sequence like this is given in the linked list. That's the here downward path means, right? Basically, if you see this 4 to 8 is here in 4, then 2, then it, so starting from 4, then it going downwards with the same values which is written in the linked list, right? Here one thing is also there, 4 2, but here 8 is not present anywhere after 2 in downward direction, right? So this is not a valid subtree. This is a valid subtree 4 to 8, right? That's what it is asking, that if there are if it is present the linked list, all the values of the linked list in the order, same in the order which is present in the subtree, then we will return true, otherwise false, right? So basically, uh, we just need to figure out for each subtree, right? We need to check for each subtree that whether this head is present or not, right? So we need to check for all that. So if we see the constraints, the number of nodes in the tree is 2500 and the number of nodes in the list is 100, right? It means the constraints are very low. If we do it in uh, a number of nodes in tree, number of nodes in tree, let's take n, and let's take number of nodes in the list as m. So it will be something goes beyond like uh, 2 into 10 to the power something like 100, so 10 to the power 4, right? 2 into 10 to the power 5, something like that, right? So this is applicable, right? This can be doable, right? So we can do it n into m, right? It means for each and every head of the values, we can check for each subtree in whole, in this particular tree which is given, right? We can do that. So let's see how we will do that. So for checking each and every possibility, we think of one thing only, that is recursion, right? Or you can tell DFS in this case, right? Depth first search, right? So what we will do in that case, we will move. So let's take the first example, which is a very good example, which is given 1 4, which is very good example, right? 1 4, then it is given like 2, then it's also a subtree like there, it's 2, and this is 8, right? This is 8 and this is 6, like something, right? So I will not make a whole tree, right? I will just make the trees which are the values which are needed, right? Just like 3, right? And this is also a 4 here. In this case it is a 4. It is taking too much time. I don't haven't thought this would take so much, but yeah, that's completed, right? So this is how this is working, right? So this is how this is the tree form, right? Let's just make this like here, some bit of here, some bit of here. Okay, okay, and yeah, that's enough, I think. This is something like this, right? So basically, this is something like the tree which is made on. So how we will iterate in whole tree and found the head which is given in the tree, right? So basically what we will do, we will simply iterate in starting from 4, then 2, then 8, right? So basically we need to figure out each subtree, we will need to figure out each path which can be valid in a subtree, right? So we will start from 4, we will start from head node, right? So is this head is equals to this 4? No, it's not, right? So basically it means from this head we can't start this head, right? So we will move to its left part, and we will check that whether this 4 is equals to this head value. Yes, it is equal, it is equal, right? So if it is equal, then we will just move this 4 this to 2, right? Then we will check for its left and right value, its fourth left and right value. So its left value is null, so we will move to its right value and check whether this value is same. Yes, it is same, right? It is same. Then we will again back to the move to the next part, which is 8, right? So 2 is left and right, we will check again, right? In left part it is 1 and this is 8, so it is not applicable. And in the right part it is null. It means we are not able to find 4 to 8 in left part of this subtree, right? So we have checked for left part, same we will check for the right part, right? So basically what was happening, that we were just making a new copy of 4 to 8. So basically what was happening, that in the recursion, when the recursion was happening, it was like this head and this root, right? So basically we need to check for each possibility. So what we will do, we will, if we get the value, if the value are the same of head and root, so we will move to the next part with the two possibilities. The first possibility would be, the root ka left, in the root left, and the second possibility would be head next in root right, right? Because we don't know now that where we will find the values in right or left. So we need to just take an or between them, right? If I get any if I get the value, same value in any of the places, either in the left or the right, we will return true in that case, because we just need to find the path, right? So either either we get in left part or right part, we will return true in that case, right? That was happening. So in the left part we don't get, right? When so we will move to the right part. So this 4 is again matching with this 4, right? So this 4 is matching, so we will move to its next part. So fourth next is 2, and fourth, and we need to move in fourth left part and right part both, because we don't know that whether where this 2 will form, right? So in this left part 2 is same, right? 2 is same. So if 2 is same, we will again iterate in forward direction, which will we get it. So we will again move in towards left and right part. So to a left part there is 6, which is not matching with 8, right? It means this will return 0, right? This will return 0. So this returns 0, but here in this right part 8 is similar to this 8. 8 is similar to this 8. It means we need to move further. So if we move further in head, head is ended, right? Now we got one base case, right? We got one base case. What is that? So if head is null, it means, we we have covered all the, we have got, we have matched all the values of head of linked list in tree, right? That's why we got null value. That's why we got null value, right? That's what we get null value. So the base case is if head is null in any of the case, in any of the case, it means all values are matched, and we got all the values in linked list in trees, right? So it means we will return true in that case. We will return simply true in that case. So, so you see that from this we got 1, from this we got 0. So but we will take odd option, because in any of the case, in any of the branches, if I got true, it means that will definitely got true for all of the cases, right? So from here 1 return, and from here 0 return, ultimately it will have a boolean value 1, which is true. So that will return true again to this part. Again this will return true, this will again return true, and from here it return false. But we are taking odd value, right? We are taking odd value, so that will ultimately return to true, right? This also returns true, but this return false, right? False, right? So this is how we solve this question basically. So basically we are moving for each and every path, and then we are just seeing that whether we are getting or not, right? So the first case is head is null. The second case, what it would be? It would be that when this tree, we got a leaf node, right? we got a leaf node. So if we got a leaf node, it means, and head is not null, it means we are not able to find this 428, right? So if we got a leaf node, and what the condition of leaf node, that root left and root right is null, or if root is null, or if root is null, or you can check that if root is null, then it means we are not able to find the matched ring, so it will return, we will return 0 in that case, right? If root is null, it means unhead is not null, it means we are not able to find this matched ring, so return 0 in that case. Otherwise we are simply move for each and every part. So the first check is that we will start from its root part, which is given tree node root and head, right? If we don't get that, then we will move to its left part and the right part, and check that whether this left part is a head or not, or right part is a head or not. So we will, so what we will do, we will move to each and every node of the tree and try to compare it with head, and then we will proceed further for the checking, right? That's we will finally do. So let's just implement it, you will understand it better what I'm trying to say. So the first thing to check is if root is null or not. If root is null, then we don't need to check anything, we will just simply return 0 in that case, that is false. Otherwise what we will do, we can, we need to check that whether this root value is equals to this head or not. So for that, what I will do, I will check for this root value, I will check for this root value to this head value, right? Also, what we will check, if this is not equal, then we will need to move further for, then we will make this its left node, each and every node as a head, right? So we will move in root left, again we will move in root left and make every node as a head, right? So basically what we will do, what is it is doing, it is making each and every node of tree as a head, right? So is a path, what is it is doing, it will move to its root left part. So it will move to its root left part and check whether, and start from this root here, that whether we have this linked list in this root or not, right? Same for root right, that it will move to its root right value and check with, and start make it as a root value and check whether this can be a starting point of this. So this is just for changing the root head node for this, and this is for checking that whether we are able to proceed further or not, right? So let's just write it here. Each subpath is subpath, it is helping to change, it is helping to change the node, it is helping to check each node and making it as a root node for for head, right? For head, and if the values are same to head, then it will move proceed further, right? It will proceed further for other checks, right? Proceed further, right? That's what this is helping. And DFS is what helping, if the if the node the node which is making as a root value is same as head, then we will proceed further for DFS, right? And ultimately we will return an answer, right? So let's just implement DFS, right? So this is DFS, and it will check for each and every value, right? This will check for each and every value. So first is head, and the second is root node, right? Now what we will check, we will check that whether this head ka value is equals to root value, right? That's the first condition. If it is equal, then what we can do, we can simply move to head next. But if you move to head next, the value can be found in left part and right part of the root also, right? So we need to move in both part. we need to move in both part. That's head next will be the same, but we need to move in right, we need to move in left and right to check for that whether we are able to find it or not. And if we are able to find it any of the case, we will return in found in that case, right? So that's why, or if any of the case is true, then we will simply return true. If both cases false, then only it will return false. Otherwise, return false. Otherwise return false if both the values is not equal. So when this DFS will end? So remember I told you the base case, right? So if head is null, it means we are able to get all the values of linked list, right? So if head is null, we will return 1. If root is null, it means we are not able to find head, all the heads, so we will return 0 in that case, right? So that's the whole concept. So understood, this is subpath is just making each and every node as a head node, and this DFS is helping us to proceed after making that node, particular node as a head node, that whether we are able to proceed further or not. That's the whole reason for it. So see, we are checking for head, for each and every head value to each and every subtree value, right? So that's why it is O of n into m, right? That way it is O of n into m. And what is n? N is the number of nodes, number of nodes of linked list, and m is the number of nodes in tree, right? And the space complexity. So if you see here, the space complexity would be the same, right? The space complexity would be the same. Why it will be the same? Because we are iterating in recursive fashion, right? We are iterating in recursive fashion. So in the worst case, it can, depth of the recursion can go to n, and the root, in the worst case, the depth of the recursion can go to at the head of the linked list, and can go to also at the end of the root. So that would be definitely O of n plus m, right? By n plus m, because this head value is moving till when it is not null, and the same goes for root value till it is not null. So it can possible that it can goes to it in whole of the nodes, that way O of n plus m, right? So this is how we solve this question. So basically it's just that you need to iterate for each and every node making as a parent, and check for each and every subtree that whether we are able to get this linked list or not. So this is how we solve this question. Hope you understand it. uh, let's just try to run this, or and we will submit it out. Yes, let's submit it. We have passed all the test cases, right? So